Virtually every well drilled requires casing and cement. Casing is steel pipe that the crew puts into the well bore. The casing prevents the hole from caving in and seals off formations. To do its job, though, the casing has to be cemented in place. A cement crew pumps cement down inside the casing and up the annulus. The cement hardens or sets to hold the casing in place. Casing is steel pipe that comes to the rig in individual joints. A casing crew couples the joints together to run them into the wellbore. To run the casing, the crew joins the joints with threaded connections called couplings or collars. Do not confuse casing collars with drill collars. Casing collars are couplings. They use special heavy-duty elevators and large casing slips, called spiders. They make up the casing joints with multi-speed power casing tongs. Power casing tongs not only screw the threaded connections together, but also torque them to the correct amount. By the time the crew drills the well to final depth, it usually has several strings of casing in it. These strings are called conductor casing, surface casing, intermediate casing, and production casing. Notice that the cased well looks something like a telescope pulled out to full length. That is, as the crew drills the well deeper, the size of the hole and the size of the casing gets smaller in diameter. Almost always, the drilling contractor cannot begin drilling at the surface and go all the way to total depth in one step. For one thing, formations near the surface tend to crumble and cave in easily, so conductor casing prevents cave-ins. For another thing, formations near the surface may also hold fresh water that the well cannot contaminate. So surface casing protects freshwater zones. For still another thing, deep formations are sometimes so-called troublesome formations. That is, they can be drilled by adjusting the properties of the drilling mud, but, once drilled, need to be sealed off to prevent problems in drilling the deeper portions of the well. So, intermediate casing seals off troublesome zones. Sometimes deep wells require more than one intermediate casing string. Finally, once the producing zone is drilled, it needs to be protected and sealed, so production casing isolates the producing zone. The first string of casing is the conductor casing. The hole drilled for it is pretty big, often as much as 36 inches or more, almost a meter in diameter. The conductor hole has to start out pretty big because as drilling goes on, the hole's diameter decreases. In some cases, the rig will hammer the conductor casing in place if the ground near the surface is really soft. If the conductor hole is drilled, the casing is cemented in it. Using a bit whose diameter is small enough to easily go inside the conductor casing, the rig drills the hole below the conductor to a prescribed depth. The diameter of the surface hole can still be relatively large, say 17 inches, over 400 millimeters or even more. The surface hole's depth is usually set by regulatory agencies. They require that the surface hole be drilled through all freshwater zones, and that surface casing be set and cemented to protect the zones from damage by additional drilling operations. This depth could be from hundreds to thousands of feet or meters. Crew members nipple up or connect the BOPs to the surface casing at the wellhead. So this casing must be strong enough to support the BOP stack. In addition, it has to withstand the gas or fluid pressures the well may encounter. Surface casing also has to be strong enough to support the additional casing strings hung inside of it. To drill the intermediate hole, the operator chooses a still smaller in diameter bit, which easily fits inside the surface casing. A bit of about 12 inches, or 300 millimeters in diameter, is one example of the size. Intermediate casing is also cemented into place to seal off troublesome formations, like lost circulation zones or abnormally pressured zones. It is often the longest section of casing in the well. Also, the crew connects or nipples up the BOPs to the top of the intermediate casing by using an adapter and casing head, or a drilling spool, which is stacked on or connected to the top of the surface casing wellhead. It therefore anchors the BOPs for the drilling that comes later. Remember that the crew has to nipple up a stack of BOPs to each string of casing that is run into the well. First, they nipple up on the surface casing. Then, on the intermediate casing. And finally, on the production casing. To drill to final depth below the intermediate casing, the rig owner selects a bit whose diameter is small enough to fit inside the intermediate casing. Say from 8 to 10 inches, or 200 to 250 millimeters. This part of the hole penetrates the producing zone. When cemented in place, production casing seals off the producing zone and readies it for production. Production casing also houses and protects the tubing and other equipment used to produce the well. The operator usually perforates, puts holes in this casing when the well is completed or ready for work to begin. Well completion is the term describing the activities and methods of preparing the well for production of oil and gas. Oil and gas flow into the well through the perforations. Sometimes well owners run liners instead of casing into the well. A liner is a shortened string of casing used to case the smaller open hole section below an existing casing string in the hole. It's just like casing, except that a liner does not run all the way to the surface. Instead, the casing crew hangs it from the bottom of a previously run casing or liner string using a special piece of equipment called a liner hanger. In this case, there's an intermediate liner and a production liner. Using liners saves money since they do not extend to the surface. Because the crew will cement the casing string in place, they also have to install some special devices on the string, which come into play during the cementing operation. The guide shoe is a heavy steel and concrete fitting that the crew makes up on the end of the first casing joint to go in the hole. It guides the casing past rough spots and ledges in the wellbore. It also has an opening in the end. Drilling mud enters this opening when the crew runs the casing into the wellbore. Later, cement will come out of this opening on its way into the annulus. Usually, the crew installs a float collar in the second or third casing joint run into the wellbore. Or sometimes they install a float shoe. Whether a float shoe or a float collar is used, each has a one-way valve in it. Fluids can flow downward through the valve, but cannot flow upward past the valve. The float collar or float shoe keeps drilling mud from entering the casing string as the crew runs it into the hole. Keeping the casing empty of mud allows the casing to partially float in the mud, that is, in the annulus, just as a hollow steel boat floats on water. Letting the casing float cuts down on stress and fatigue on the hoisting equipment. But the crew cannot keep the casing totally empty of mud. If they did, the hydrostatic pressure of the mud in the annulus could crush the casing. So from time to time, the crew puts mud into the inside of the casing from the surface to offset hydrostatic pressure. The float valve also holds the cement in place once it is displaced into the annulus. Otherwise, it would U-tube back into the casing. On various joints of casing, crew members also install centralizers. Centralizers keep the casing from leaning against the side of the hole. In other words, centralizers keep an opening between the outside wall of the casing and the wall of the hole. Centralizers reduce drag and differential sticking while running the casing. Drag is resistance to motion caused by the casing contacting the wellbore. Differential sticking happens when the casing contacts a permeable formation in the wellbore, and the pressure in the hole is greater than the pressure in the formation. The higher hole pressure tends to hold the casing in contact against the area of lower formation pressure. Keeping the casing off the wall of the hole also ensures that cement will surround the outside of the casing and bond it securely to the hole. Another device that helps ensure a good bond of cement to the hole is a scratcher. Depending on the wellbore's characteristics, crew members install several on the casing string. Just before they pump the cement into the casing and hole, they rotate the casing string. Or move it up and down, that is, reciprocate it. Depending on the type of scratchers they install. In either case, the scratchers remove wall cake left by the drilling mud during drilling. Removing the wall cake, solid particles in the mud that stick to the wall of the hole, helps the cement bond better to the hole. Here is an overview of casing cemented in a well. Called primary cementing, the cement's main jobs are to completely isolate or totally seal off all the oil, gas, and water zones from the wellbore, and to bond the casing firmly to the wall of the hole. Here, the crew has drilled the well to the casing point. the depth at which they will set and cement casing. The driller circulates drilling mud to clean the hole and to make sure the mud is in good condition. Then, the crew pulls the drill string out of the hole. The next step in primary cementing is for the casing crew to run the casing into the well, one joint at a time. Notice at the bottom of the casing the guide shoe and float collar. Also notice the centralizers and scratchers. The guide shoe guides the first joint of casing into the well bore. A valve in the float collar lets the crew float the casing into the well to lessen the load on the rig's hoisting system. Centralizers keep the casing off the wall of the hole to ensure a good cement job. And scratchers remove wall cake to ensure a good cement bond to the wall of the hole. The cementing crew next readies a cementing unit. The cementing unit rapidly mixes water, dry cement, and special additives to the cement to make a liquid cement slurry. A high-pressure cement pumping unit moves the slurry down the casing. To get the cement slurry down the casing, the cementing crew makes up a cementing head, also called a plug retainer, on the top joint of casing suspended in the rig's elevator. The cementing head has an inlet for the cement slurry from the cement pump. Slurry enters the head at the connection on the side. The valves on the head allow the crew to control the point at which the slurry enters the head. From the cementing head, the slurry goes into the casing. The head also holds special plugs called wiper plugs. The wiper plug retainers keep the wiper plugs in the head until the crew releases them to allow the plugs to be pumped down the casing. The fluid inlet allows the crew to pump mud, water, or a special displacement fluid, the fluid that pushes the cement into the annulus. This head holds two wiper plugs, a bottom wiper plug and a top wiper plug. The bottom plug goes into the casing first. It wipes mud off the inside of the casing and separates the mud from the cement. The top plug follows the last of the cement into the casing. It wipes cement off the inside of the casing and separates cement from the displacement fluid. Cement pump pressure moves the cement slurry to the cementing head, where a crew member releases the bottom wiper plug. Slurry pushes the bottom plug down the casing until it seats in the float collar. When the plug seats, continued pump pressure on the slurry ruptures a diaphragm on the bottom of the plug. This allows cement slurry to go out the guide shoe and into the annulus. When the calculated amount of cement slurry has been pumped, a crew member releases the top wiper plug. Displacement fluid forces the top wiper plug down the casing until it seats in the float collar on the top of the bottom plug. Because the top plug is solid, pump pressure rises when the plug seats. A sharp rise in pump pressure signals the pump operator to shut down the pump. The float valve holds the cement in place, not allowing it to U-tube back into the casing once it is displaced into the annulus. The cementing job is complete. Depending on hole conditions and the type of cement used, the cement slurry hardens or sets up firmly, generally within 12 to 24 hours.